All right, so we had started with reaction kinetics and I told you order. What is order? Order is the power to which the concentration of a reactant is raised to in the rate equation. I told you you could figure out the order by looking at the overall rate equation. For example, here we say that rate is second order with respect to A, it is first order with respect to B, zero order with respect to C. Order can also be determined using graphs. I told you that order can either be zero first or second order with respect to a reactant. The rate concentration graphs are different for all three orders, but the concentration time graph, you can use that to determine the order. How? You can calculate the half-lives. If the half-lives are decreasing, that means if T1 is greater than T2, which is greater than T3. So you see there's a decrease in half-lives. So if successive half-lives decrease, that means it would be zero order. If successive half-lives increase, then it would be second order, like this. And if successive half-lives are constant or equal, then it would be first order. So you can't just, by looking at the rate concentration, graph, you can tell the order because they look different for all three. But the concentration time graph, it kind of looks the same for first and second order. So you have to calculate the half-lives and see the trend. If it's equal, first order. If it's increasing, second order. If it's decreasing, zero order. Yeah. Now, I also told you that you could determine the order by the initial rate data. For example, right here, you've been given the experiments and you've been given the change in concentration, how the rate changes. So using this, you can also determine the order. For example, if you want to find out the order with respect to NO, then you must take two experiments where the concentration of NO is changing and bromine is constant. And you can see the change in concentration and how that changes the rate. Likewise here, if you want to find the order with respect to bromine, then you must pick two experiments where bromine is changing, NO is constant. And you can find out the order with respect to the change in concentration. Clear? Now, let's have this question and let's try this. Let's have you try this question. So you need to find the order with respect to ICl and with respect to hydrogen. So we need to pick for ICl, you need to pick two experiments where ICl is changing concentration and hydrogen is constant. So let's pick two experiments. So let's take for ICl, which experiment should we take? Can we take 4 and 5 because ICl is changing and hydrogen is constant. So experiment 4 and 5 for the concentration of ICl. Now, how is the concentration changing? Let's see. So it is going from 5, 10 to the power minus 3 to 7, 10 to the power minus 3. So the concentration is changing by 1.4. So this is changing by 1.4. Let's see the rate. How is the rate changing? The rate is going from 2.5 to 3.5. This is also changing by 1.4. So since the rate is changing by the same amount as the concentration, can we say that it is first order with respect to ICl concentration? Yes. Now, we need to find the order with respect to hydrogen. So with respect to hydrogen, let's pick two experiments where ICl is constant and hydrogen is changing. So you can take 1 and 2. You can also take 2 and 3. You can also take 1 and 3. Yeah. So you can take either or. I will take experiment 1 and 2. So let's see. Experiments 1 and 2 for concentration of hydrogen, where hydrogen is changing and ICl is constant. Now, what is the change? It goes from 4 10 to the power minus 3 to 7 10 to the power minus 3. And this changes by how much? It changes by 1.75. Let's see how the rate changes. The rate also goes from 1 to 1.75. This also changes by 1.75. So you see the rate is changing by the same amount as the concentration. So this is first order with respect to hydrogen as well. Clear? So if you take it with experiment 2 and 3, then it will be changing by the same amount as this. They will be changing by the same magnitude. So you will do 1 10 to the power minus 2 divided by 7 10 to the power minus 3. That comes out to be how much? 10 to the power minus 2 divided by 7, 10 to the power minus 3. This comes out to be 1.42 something. And then you do 2.5 divided by 1.75. That is also 1.42. So if you do this and this, if you take these two, this changes by 1.42, and then the rate also changes by 1.42. So that's also first order. This is changing by equal magnitude. So we know that it is first order with respect to both. Let's see part B. So this was part A. So part B would be the rate equation, which would be rate is directly proportional to ICL, and it is first order. So it will be raised to the power 1. You don't really need to show power 1. And then you can substitute the proportionality sign with K, which is your rate constant. Clear? So this is what it is. Then they're saying use experiment 3 to find the value in units of K. So let's see how we do that. So experiment 3, what is the rate? The rate in experiment 3 is 2.5. So it will be 2.5 is equals to K, which we don't know. And then we have the concentration of ICL, which is 410 to the power minus 3. And then we have the concentration of hydrogen, which is 110 to the power minus 2. And then you calculate the value of K, which comes out to be how much? 62,500. Now let's find the units of K. So the rate would be in mole per dm cube per second is equals to K. This would be mole per dm cube. This would also be mole per dm cube. So you will divide these mole per dm cubes right here. So can I say this would be mole per dm cube and another mole per dm cube right here? Yeah. And then you cancel this out with this. And you will be left with what? You will be left with K is equals to mole minus 1 dm cube per second. So what are the units? Mole minus 1 dm cube per second. Clear? All right, let's have you try. Okay. So see this question. So we have nitrogen monoxide, they're saying, and reaction when it is heated to a temperature, they're asking you to select dot and cross with electronic structure of nitrogen monoxide. You know oxygen makes how many bonds? 2. Yeah. So this will be a double bond right here. So we have nitrogen and we have oxygen. So this is nitrogen, oxygen. Between nitrogen and oxygen, there's a double bond. So 1, 2, 3, and 4 electrons being shared. Oxygen has 6 outer electrons, 2 are being shared. So this is 3, 4, 5, and 6 would be a lone pair. Nitrogen has 5 outer electrons. So 2 are right here. This is 3, 4, and 5. Now, they've given you, they're saying the enthalpy change of formation of nitrogen monoxide is 90 kilojoules per mole. What is formation? Formation is when 1 mole of something is formed from its constituent elements. What will be the constituent elements of nitrogen monoxide? Nitrogen and oxygen gas. So 1 mole of NO being formed from its constituent elements in their standard state under standard condition is called enthalpy change of formation. And they've given you the value of this. They've told you that the formation of 1 mole of NO is plus 90 kilojoules per mole. They're saying what is the enthalpy change of the following reaction? Now in this, you see you have 2 moles of NO. So if I make 2 moles of NO, what will be the enthalpy change? If 1 mole is plus 90, 2 moles would be plus 180. Now they are asking you the enthalpy change of this reaction, which is the reverse reaction. Yes, so that would be what? Minus 180 kilojoules per mole. Explain why nitrogen monoxide is formed in the car engine. Because it is facilitated by the high temperature. So there is high temperature in the combustion engine or in the car engine, which favors what? Combustion of nitrogen. Yes, and nitrogen is present in air. So using bond enthalpy values from the data booklet and the answer to part 2 above, calculate the bond energy of NO. So we know that delta HR is equals to bonds broken minus bonds formed. Bonds broken will always be of the reactants. Bond formed will always be of the product. Delta H is given to us. We just calculated it actually, minus 180. Bonds broken will be of the reactant. We need to find this bond energy. Can we call this 2x? Minus bonds formed. What are the bonds formed? Nitrogen. The bond value for this is 944. You can get this from the data booklet. Nitrogen right here is 944. Oxygen is 496. So plus 496. And when you calculate this, this comes out to be minus 180 plus 944 plus 496. And that is 1260 divided by 2. That is plus 630. That becomes your bond energy. Clear? And you see the answer is correct because the value is coming out to be positive. Bond enthalpy is always positive. If in case your answer was coming out to be negative, you must have made an error during your calculation. Bond enthalpy is always positive because it's an endothermic reaction. Now they've given you this and they're saying find the order with respect to each reactant, explain how you got to your answer. Now instead of concentrations, they've given you partial pressures of gases. So you'll use the same method. Now for hydrogen, you will pick two experiments where hydrogen is changing and NO is fixed. So which experiment should I take? You will take 1 and 3. So you should choose experiment 1 and 3 because this is changing and this is fixed. So let's see what the change is. So when you go from 1 to 3, it goes from 0.64 to 0.32. And this comes out to be 0.5? Yes? So this is 0.5. So the rate, let's see how the rate changes. So the rate changes. It goes from 1.5 to 7.5 10 to the power minus 8. And this also changes by what? 0.5. So this is also changing by 0.5. So can we say it is what? First order with respect to hydrogen. Let's see for NO. So let's check the order for NO. So for NO, let's take two experiments where NO is changing and hydrogen is fixed. So which experiment should we take? 1 and 2? So let's see, it is going from 1.6 to 0.8. So 0.8 divided by 1.6, that is 0.5. So the concentration is changing, or not the concentration, partial pressure is changing by 0.5. Let's see how the rate changes. So the rate goes 3.75 10 to the power minus 8 divided by 1.5 10 to the power minus 7. And this comes out to be 3.75 divided by 1.5 10 to the power minus 7. That is 0.25. So you see, this is becoming half. Yeah, so this would be what? Second order with respect to NO. So we know that it is first order and second order. If they ask you to write the rate equation, what would that be? Rate is equals to K, partial pressure of NO square, partial pressure of hydrogen. Clear? You won't write concentration. Why? Because partial pressures are given. Clear? And then your K would be in ATM. Something in ATM, right? Not mole per DMQ. They've given you rate as ATM per second. So then it would be in ATM per something. All right. Now, let's try another question. All right. So let's go over this now. So if they say the first step is a slow step. Now I told you that the rate equation can never be determined by the overall reaction. It is always determined by the slow step. Now you have 3 steps right here. Also, I told you that reaction happens through, most chemical reactions happen through a mechanism where you have multiple steps and then you add those steps and then you get the overall reaction or the overall equation. I also told you one more thing. I told you that there are certain species which we call the intermediates, which are formed in the reaction and they are used up in the reaction. And how do we identify the intermediates? Intermediates will never be part of the overall equation. Do you see? Like N2O2, do you see that here in the overall? No. So that means it's an intermediate. Likewise, N2O, do you see that here? No. So that means it's an intermediate. And I also told you that intermediates never are part of the rate equation. Now let's see. They're saying if step 1 is your slow step. So if this is your slow step, what will be the rate equation? Rate equation would be rate is directly proportional to the reactants of the reactants in the slow step. And what are the reactants in this? NO. How many NOs? 2. So can I just write this as 2 moles of NO? Yeah. And the mole or the stoichiometric coefficient goes as the power. So that would be rate NO raised to the power 2. Yes. Or can I say it is second order with respect to NO? Yeah. So that is for your first one. Let's see the second. Now in the second one, let's see your slow step is the second step. So let's see if this is your slow step, what will be our rate equation? So rate would be directly proportional to the concentration of the reactants. What are the reactants? N2O2 and H2. Now, if you look here, N2O2 is an intermediate. And I told you intermediates can never be part of the rate equation because they are formed and then they are used up. So they don't really make it to the rate equation. So then what do? This is an intermediate. Now you see, how is this intermediate being formed? This intermediate is being formed by two NOs. Do you see that? So can I replace the N2O2 with two NOs? Can I replace this with NO and another NO because they make up N2O2? And the two NOs basically can be written as what? NO squared and H2. So the rate equation therefore becomes rate is directly proportional to NO squared and H2. Why not N2O2? Because it's an intermediate. And why did we write NO square? Because N2O2 is being made by two NOs. Clear? Let's now see if your third step is your rate determining step. What will be your equation? Now, again, it would be rate is directly proportional to the concentration of the reactants. What are the reactants? N2O and H2. And again, N2O is what? Intermediate. Because do you see it is not part of the overall reaction? So N2O is an intermediate. Can it be part of the rate equation? No. So how is N2O formed? N2O is formed from N2O2 and H2. So can I substitute this and write N2O2 and H2? And the H2 that we had here, we can write that as well. But again, N2O2 is an intermediate. So you can't write N2O2. Can I substitute this with NO? And you have H2. So what does it become? Rate is directly proportional to, can I say NO raised to the power 2? Yeah. And H2 raised to the power 2. Is that clear? So this becomes your rate equation. Let's have you try this. Let's have you try this. Question number 8. If I tell you, determine the rate equation if second step is the slow step. So if this step is the slow step, what will be your rate equation? Let's see. So can I say that rate would be directly proportional to the concentration of the reactants? What are your reactants here? IO minus and H plus. Now, if you look at IO minus, is it part of the overall reaction? No. So can I call it an intermediate? Yes. Can it be part of the rate equation? No. And how is the IO formed? IO is formed by these two guys. So can I say instead of IO, I can write H2O2 and I minus. And we had H plus as well. So your rate equation becomes this. This is not what they've asked in this question though, but like I've just put a question similar type for you. Is this clear? Do you all understand this? Any questions?